So, don't forget, the next 3 Tuesdays, we have formatives in the Resource Center, and the next 3 Thursdays, we have quizzes and a test in class. So, that's, and that'll take us up to spring break. So, 3 weeks of spring break. Okay? All right. Here we go. We're going to talk 12.2. I've divided 12.2 up into 3 separate days. Okay? So today we're going to talk about arithmetic sequences and series, and we're going to develop rules, etc., for them. And then, actually, today we're going to talk more about sequences. Monday, we will talk more about series, okay? Finding the sum of an arithmetic series. And then Tuesday we'll have a formative. And Wednesday, then, we will talk about real-world problems, word problems, real-world examples of using sequences and series and things of that nature. So, okay, in arithmetic form. Okay. And then we'll quiz on the 7th. Okay? So, sequences and series. A tall brick building has a decoration as shown. Okay? If each row is 1 foot tall, okay, how many bricks would be in the bottom row if the wall is 15 feet tall? Okay? And not only that, but how many bricks would it take to build that wall, or to build this design in that wall? Okay? Now, that's a typical problem for this section from this chapter. Okay? That's a real-world example. Okay? You're designing something, and it's got a pattern, and that pattern is constant. And how many bricks do I need to go? When I go to Menards to get the bricks for this, how many bricks do I need to buy? Okay? Because you're not just going to go to Menards and buy, 1,000 bricks if you're only going to use 20. Okay? You be smart about these things. Okay? In a couple of days, we'll be able to solve both those questions. Actually, at the end of today, we should be able to solve the first question, how many bricks are in the 15th row. Okay? And on Monday, we should be able to solve how many bricks it would take to actually build the wall. Okay? So, an arithmetic sequence is a sequence that has a constant difference between consecutive terms. Okay? So, we did a couple of homework problems. I don't remember what number it was that you said it was, but that was an arithmetic sequence because we were subtracting 1.6 to every term to get the next term. Okay? So that one was an arithmetic sequence. Okay? Okay? So in layman's terms, in Linzmeyer terms, if you will, it's a sequence that you add to get, actually I shouldn't say add to get, I should say add, here I'll just write out the word, add a constant to get next term. Okay. I wrote it twice, I don't know. State whether the sequence is arithmetic. So in this first one, okay, what you have to do, now I see what, okay, what you have to do is you have to look at each term. And so to go from here to there, we do what? Add 4. Okay? So if it's arithmetic, then I would add 4 to get to the next one. Yes? If it's arithmetic, I would add 4 to get to the next one. Yes? If it's arithmetic, I would add 4. Oops, it didn't go all the way. I would add 4 to get to the next one. And yes, that one is arithmetic. You find the difference between consecutive terms, and so it's always being added by 4. So, yes, sir, that is arithmetic. What about this next one? Remember, you're adding. Okay? So if I add to get, what would I add to get from 20 to 15? So I'm adding a negative 5, right? Because we're subtracting 5, okay? So then I would have to subtract 5 to get the next one. And subtract 5 to get the next one. Yes all the way through? If it's a yes all the way through, then yes, it is arithmetic. If it was like when Marley told me 2.1, negative 2.1 on that one, that would then not become an arithmetic. Okay, because it was subtracting 1.6 and it was subtracting 1.6 and it was subtracting 1.6, but then it was subtracting 1.5. That's not arithmetic then. Okay, it's got to be constant throughout the whole thing. Okay? So, with that being said, what I would like you to do is I would like you to determine if this sequence is arithmetic. And if it is arithmetic, I would like you to tell me what the common difference is. That's what that number is called, the common difference. First one, arithmetic, not arithmetic. Yes? What's my common difference? 10. I'm adding 10 every time. So yes, I would concur because here it is plus 10. And then here it is plus 10. And then here it is plus 10. And so on and so forth. So I would say that yes, this is arithmetic. And D is the symbol for common difference, and my common difference is a positive 10. Okay? B, yay or nay? Is it arithmetic? Why not?
Because it's adding 3, then adding 5, and then adding 7.
Yep, exactly. So we went plus 3, and then we went plus 5, and I don't have to go any further because those two numbers are not the same. Okay? So you disproved that it is arithmetic. C, yay or nay? Yes or no on C? Arithmetic? Yes? Why do you think it's arithmetic, Anthony? Tap the brakes. That's not arithmetic. That's geometric. Because we have to add. Okay? The definition of an arithmetic is it's got to add. Okay? We got to add a constant. So I'm only looking at adding. So here it would be plus negative 9. Here it would have been plus 18. So this is a hard no. Okay? Yes, I'm multiplying by negative 2 each time, but that's geometric. That's next week Friday. Okay? Okay. D, yay or nay? Yes? What's my common difference? Negative 12. I subtract 12, and then I subtract 12, and then I subtract 12. Always do that. Yep. Yep. With an arithmetic sequence comes a general rule for the arithmetic sequence. Okay? This is the general rule for an arithmetic sequence. Okay? The last term, or really any term, the term that you're looking for, is equal to the first term plus the number of terms, or the term number of what you're looking for, minus 1, times your common difference. Okay? So with that being said, you have to know the first term in order to write the sequence, or to find a term in the sequence. You have to know the first term. With that being said, you must know the common difference between two consecutive terms. The number of terms, or the term number, that's going to be given to you. And I'll show you where it will be given to you when we get into writing some rules. Okay? Or when it is finding a specific term number, that is. Okay? If you're just writing a rule, n is going to stay n. Okay? So a sub n will stay a sub n, and n will be your variable in your rule. Okay? Let's put it to work. Here we go. Okay? So first off, get rid of that because there's our rule again. Okay? Directions. Write a rule for the nth term and then find the 20th term. Okay? So I like to, whenever, and I found that this strategery works the best because it's brand new to you again, or haven't necessarily remembered all of it. Start by rewriting the basic general rule every time. So start with a sub n equals a sub 1 plus the quantity n minus 1 times d. Okay? Start with that every time. Why? It's going to transfer it over into your long-term memory much faster. You'll understand how to use it much better. You'll have a deeper understanding of everything that's involved with it if you start with it. Okay? Actually, I wouldn't start there. I would first start by writing the sequence down on my paper. Then I would do the second thing, and I would do this. Okay? Because then you have something to go back and reference. I don't know. I'm writing a rule for the nth term, so a sub n here is going to stay a sub n. Do I know the first term of this sequence? 1. No, it's 1. It's right here. I don't know n, so it's going to stay n because I need to make my rule. Now I just need my common difference. What is my common difference? Positive 2? Because we're adding 2 every time to get to it. Okay? So we have that. Now, here's the wonderful thing about the maths. Okay? This is a rule, therefore it can be your answer. Okay? Or you could make it look a little prettier, because we usually put that number out in front of the parentheses, right? Or if I distributed that 2n, I'd have 2n minus 2, right? So 1 plus 2n minus 2 is 2n minus 1. All of those, oops, not A, arithmetic's on the brain. All of those are acceptable rules in my eyes for this sequence. Okay. Basic, standard, advanced. Okay. Wherever you want to fall. Totally up to you. Okay. Which one is easier to use in the going forward? Advanced is the easiest one to use going forward. Okay? But by no means, you can use basic, you can use the standard, or you can use the advanced one. Okay? Then it had asked us to find a sub 20. Okay? So then it wants us to now find out what a sub 20 is. Okay? Which is another way of saying what is the 20th term in this sequence. Okay? So what that means is that this number here is n. It's my term number. I want to find the 20th term. I have the first 4 terms. I'm not going to keep going because that's going to be a lot of work to find the 20th term. So I can take 20 and replace it or substitute it in for n in any one of my rules. Okay? So then this would be 2 times 20 minus 1. 2 times 20 is 40, minus 1 is 39. So the 20th term of this sequence is 39. Okay? So, what I would like you to do now is I would like you to find me an arithmetic sequence and the 20th term for letter B. I'll give you 2 minutes. Shouldn't take you much longer than that. I get 6 for my first term, and I got -4 for my common difference. That gives me a sub n is equal to 6 plus the quantity n minus 1 times -4 as my basic. that gives me a sub n equals 6 minus 4 times the quantity n minus 1 as my standard, and that gives me a sub n equals negative 4n plus 10 as my advanced. Then to find the 20th term, I'm going to put 20 in for n, and that is going to yield me negative 80 plus 10 is negative 70. Yes? Okay. All right. Another style of problem is to give you a term somewhere in the sequence and the common difference. Okay. So I've given you the 6th term in the sequence and the fact that d is equal to 9. Again, I would start with writing down the formula for the rule. The arithmetic rule is a sub 1 plus n minus 1 times d. Okay. A sub n is going to stay a sub n. N minus 1 is going to stay, and actually tap the brakes. Hold on. Whoa, whoa, and whoa. A sub n and n are not going to stay. I've got to reset this. All I was thinking like the next one. Okay? So a sub n is going to be negative 16 because that's the term that I'm given. That's any term in the sequence. Okay? I don't know my first term. I gotta find it. But I do know that negative 16 is the 6th term in the sequence. And I do know that 9 is the common difference. And I can solve that for my first term. 6 minus 1 is 5. 5 times 9 is 45. I can subtract 45 from both sides, and that gives me that my first term is negative 61. Now that I have my first term, and now that I have my common difference, now I can go and I can say that this is my nth term is equal to negative 61 plus n minus 1 times 9 as my basic one. I could say that a sub n is equal to negative 61 plus 9 times the quantity n minus 1 as my standard sequence. Or I could say that a sub n is equal to 9n minus 70 as my advanced. it also asked us to find the 18th term in that particular sequence. So we need to find the 18th term. Oh, 9 times 18, 72, 162 minus 70 is 92. Questions on that? Work it out. Find me the rule. Find me the 18th term in D. So again, I start with the rule. And my common difference is -7. My term is that one, and then I know I'm changing up colors, new color scheme. Okay, so -3 here, that's red, -3 is going to equal my first term I don't know, a plus n is going to be 12. Minus 1 is -1, and D is -7. So that gives me -3 equals a sub 1 plus 12 minus 1 is 11. 11 times -7 is -77. So really we could have, let's make this even look prettier, we could have written this as -77. Add 77 to both sides and I get 74 is my first term. If 74 is my first term, oops, I kind of need that, then I've got a sub n is going to equal 74 plus n minus 1 times -7, and I would put that -7 in parentheses if you're going to go basic, just because then it doesn't look like -7 on the tail end there. Okay, or we could write a sub n is equal to 74 minus 7 times the quantity n minus 1, or we could write a sub n is -7n plus 81. Again, basic to advanced. You will find on Monday when we get into summation notation that advanced is good, okay? And not very hard to get to either. Okay? Then it asked us to find the 18th term of said sequence. So the 18th term is -7 times 8 is -126 plus 81 is -45. Agree? Okay. So, the last style of problem is the, I don't want to say the more difficult one, but obviously we're ramping up towards, upper level math. Okay? And so that is writing a rule given two terms. The problem with writing a rule given two terms is that it's not do this and then you get your answer kind of a deal. What you have to do first is you have to write a systems of equations using your rule. Okay? So you're going to have to employ your rule twice, once for each term. Okay? What I mean by that is, I'll do it in green and purple. So I'm going to take this term here in green. So my 8th term is 21. So that tells me that, using my rule, that tells me that 21 is equal to my first term plus 8 minus 1 times d. If I utilize my rule just on the green box, I get that. If I simplify that and I make that look pretty, I get 21 is a sub 1 plus 7d. Now I go over here and I say, awesome. Now I got to do that again. So 97 here is equal to my first term plus 27 minus 1 times d. Which tells me, if I make it look pretty, 97 is equal to a sub 1 plus 26d. Okay? Now, what I have to do is now I have to solve that system, because I've got two equations with two variables. We've got graphing if we wanted to graph it. We've got substitution if we wanted to substitute it. We've got elimination if we want to use elimination on it. Looking at it, what do you think? Graphing, yay or nay? Heck no. Okay? Substitution, could we solve one of the equations for one of the variables? Yeah. Elimination, could we do elimination on it? I'd probably do elimination. I'm a big fan of elimination because we have a sub 1s in both cases. So all I've got to do is multiply one of my equations by a negative 1. I'm going to pick multiplying the green one by negative 1. Then regular purple. Add them together. My first terms are eliminated. Negative 21 plus 97 is 76. Negative 7 plus 26 is 19. 76 divided by 19 is 4. So D is 4. Agree? Okay. If D is 4, do you want to plug it back into green or into purple? Green, smaller numbers, I would concur. Okay. So then this would be 21 is equal to a sub 1 plus 7 times 4. 7 times 4 is 28. Oops, I put double equal sign. Tappeth, L breaketh. So I get negative 7 is a sub 1. Now you have enough information to write the rule for a sub n. Okay? So now we can say here, well, this is a sub n is equal to negative 7 plus n minus 1 times 4. Or and there's my rule. Okay? Try one. Then 25th term. Oops, don't too far. So 9 times 25, what's that? That's 225 minus 5 is 220. Agree with that? Speak now, forever hold your peace. Yeah. Fantastic. That's done. I'm it. I'm done. Okay. Now, it says in the directions for this one to graph the graph the rule or something like that. I don't remember what the directions say. No. Okay? Just find the rule. Okay? Just find the rule.